Okay, so now my dedicated SQL pool is actually completely deployed. You can see right now it's showing me your deployment is complete. I'll click on go to resource and then it's showing me that yes, my dedicated SQL pool is actually listed in this particular list. So this is available with DW100C. Anytime if I want to change the configuration of the dedicated SQL pool, or if I want to scale it, I can go inside this and I can scale it. Or if I'm not using this anymore, then I can pause this also, which can stop the costing of this dedicated SQL pool actually. I'm not doing anything. For me, my dedicated SQL pool is up and running. So let's go to the Synapse workspace. I want to click on data and then I want to focus on this workspace tab if it is showing me my dedicated SQL pool database or not. For you, if it is not showing, it's a quite common issue actually. You can refresh your full browser in the Synapse Studio and then it's going to show you that dedicated SQL pool database. You can see for me it's refreshed and it's showing me now in SQL database. I have one database actually. If I expand this, this is going to be my dedicated SQL pool database. Is it having any tables inside that? Well, obviously right now it's not going to have any tables inside that, but it is actually going to have some system views inside this. Because this is not a normal SQL Server database, it's a data warehouse. This is going to show you that we have some system views which we can use whenever we want to deep dive into this data warehousing. Anytime when any query is executing actually, if I want to see that which node is used, what kind of tables are using inside that, what kind of meta stores are getting generated in the background with the metadata details of this particular query executions, all these things I can get if I deep dive into all the system views. I am going to show you some queries with the system views right now. So let's see how it is going to work. But yes, this is what we have right now. We have a dedicated SQL pool, which is my data warehousing. And then this is having no tables right now. Let me create and execute some queries on this so that we can get some tables. So I'm going to create a new empty script right now. In the right side section, it's showing me that I'm connected to my dedicated SQL pool, and this is using this database, which is created inside that. Let me execute my first query, which is going to create a very simple table initially. So I'm going to create one table, which is with this particular query. I copy pasted this query and let me just show you what I have done inside this. I'm creating one table, which is actually having 3 columns inside that: order ID, order date, and order description. Every time we are going to have a default column value for order description, which is like new order. And when I'm creating this table, I am intentionally specifying that this particular table is actually going to have distribution of that which is of type round robin. Now for your kind of information guys, when we are dealing with this particular tables, we have two kind of distributions. We have round robin distribution and we have hash distribution. Round robin is going to allow me to distribute my records randomly and evenly, which means that if one particular distribution is trying to insert or work on one particular record, the moment the distribution is free, the same distribution can actually process multiple records with that. We'll see this thing in action once we execute some insert statement on this particular table. So my first query is very simple. If I run this query, it's going to show me that the query is executed successfully within few seconds. And then if I expand this tables kind of section, I will be able to see that I have one table which is actually dbo.orders. And this dbo.orders table is going to show me that I have 3 columns inside that. This is my table which is actually having round robin distributions with that. Once this table is created, I want to insert some records inside this. And I do not want to insert manually one by one record. I want to insert multiple records in one shot. That's the reason I have created one more query. If you see, I have declared one integer variable on the top, which is I. And then I'm setting the initialized value of the I, which is 1. I'm declaring one more variable, which is date, which is of type date time. And then I'm going to set some particular date with that. After configuring this thing, I'm actually going to set up one while loop where I'm just specifying that this while loop is going to execute 60 times. And then during the 60 executions, it's actually going to insert 111 record every time with the increment of value of I. Every time when I'm inserting this 60 records inside this particular query, I am just making sure that the date which I am inserting into this particular table is going to be same. You can see I'm not changing anything in the date. The default date which I'm giving is going to be 4th of February 2017, and that's the one which is going to be used throughout this query execution. Once this is like this, let me run this query. This query is going to be executed right now on this dedicated SQL pool with a very limited compute associated with that, because we have selected the minimum performance configuration of DWC, which is 100C. So let's wait for some time. It's going to take some time, few seconds. You can see that in the bottom bar is showing me that this is taking few seconds of time right now. Once this is done, we will move forward and we'll see that what kind of configuration we have done. I hope you agree with me that this is going to insert 60 records with a different kind of order ID, but similar kind of order date and description. Yes, my query is executed. It took around 39 seconds to execute this thing. And obviously 60 records are inserted with that. If I try to do select star from table name, I'll be able to see those 60 records. But I do not want to get those records because the data of the record is not important for me. What is more important for me is what kind of distribution they have used when they have inserted this data. And that is something which I want to know from my another query, which I'm going to share it with you right now. This query is actually selecting some particular rows and some columns actually from this particular section. So what I'm trying to do is I'm trying to apply some joins. And these joins are not happening on my tables. These joins are happening on my system views, which are already created inside this particular data warehousing. If you see this query, I'm trying to apply 1, 2, and 3 joins actually. Each join is allowing me to map my node ID kind of column with that, and is allowing me to see what kind of node ID is actually going to be used while executing this query. You can see here on the top, we have 4 columns which we are focusing right now. We are focusing on table name, which will be obviously orders. We are focusing on node ID, which should be same right now because we are using only one node ID. This is going to be my compute node ID. And then we have a distribution ID, which should be obviously starting from 1 to 60. It should be the range of that. And then with each distribution, how many rows are going to be processed? That is something which I want to see. And that's why I'm taking this thing from the node partition table. This full configurational views and the query which I'm executing is going to show me the details for orders table, and then it's going to show me the distribution order by distribution ID, and then it's going to show me all those things order by distribution ID, which is going to make sense. Let's execute this query. It's taking time. The query is executed. You can see I got some table and chart kind of section here. The table is showing me that we have 4 columns. And you can see right now the table name is orders. The node ID which is used here is actually 50. When you execute this query, you can get any different ID with this, but the rule is in all the records you're going to have only one same ID because everything is getting executed in one single node. And then if you see the distribution wise, we have 60 distributions. So we have starting from 1 to 60, which is actually visible here. And then if you focus on the number of rows processed with these distributions, then you will understand that some distributions are actually processing no rows. In that we have 0. While there are some distributions which are actually processing 3 records, 2 records, 3 records. So it means there are chances that some distributions are actually going to insert 1 record and then they are going to be free again, and then they are going to insert 1 more record with that. So there are few distributions which are randomly getting a chance again, and then there are few which are not even getting a single chance, and that's why they are not inserting any rows. This is how round robin works. Now if you want to know how a hash distribution is going to work, I am going to show you that thing very soon, but that simply means that this is something which is round robin one, so you should be clear with this first. Now obviously this thing is very straightforward, that if I try to utilize this thing with my performance of my DWC. Now once this query is executed, I want to try few more things actually. So let me just quickly execute 3 queries now. I'm going to remove this query and I'm going to create my 3 queries. First query is I'm going to create one more table, which is actually orders to table. This is another table which I'm creating. The only difference which is there is this time is orders to table is actually going to have distribution which is hash. And this time I am specifying that my hash column is going to be order date. Now remember guys, when you create a hash based table, you have to specify one hash column. Logically, the hash column has to be the one which is going to have some unique distinct values associated with the table. Now in this case, order date is not going to be the one which is going to have the unique values every time. But still I'm putting it order date just to understand that how the hash distribution is actually working. Logically, if I want to do this thing in the realistic database, then I should do this thing with my order ID, because logically order ID is the one which is going to be different every time. But intentionally, just to understand this thing, I'm putting it like this is going to be order date. I'm going to execute this query and this table is going to be created very quickly.
Hey guys, sorry for interruption. My name is Maruti and I'm here to make a very important announcement. I hope you are liking our videos and you're doing a continuous learning with us on an Azure Cloud and AI related topics. If you are enjoying this thing, I'm going to announce skilltech.club, which is our upcoming website, which is going to be launched very soon. We are here to tell you one thing, that everyone who is a subscriber of this particular channel will get Azure Cloud and Azure AI related certification courses free of cost in skilltech.club. So you will be a part of the skilltech.club kind of a membership automatically free of cost. And everyone who's a subscriber of this particular channel will get those benefits which are available in that. So what are you waiting for? I request you to please subscribe to this channel and share it with your friends and families if they are also interested in Azure Cloud and AI learning. That's it from my side. Now you can carry on with your learning. Thank you.
I'm going to execute this query and this table is going to be created very quickly. Yes, it is showing me within a second it is executed. If I refresh this section, I'm going to get one more table now, which is dbo.orders2. Same like my previous query, I want to insert some 60 records inside this orders2 also. So I'm going to execute my second query, which is actually inserting data. But this time the only difference is I want to insert records into the table which is having a name orders2. So in this also I'm going to insert 60 records. Everything else is actually same. Let me run this query, and if this is inserting 60 records into orders2 table, I want to execute the third query also, which should show me a distribution ID and number of rows processed by each distribution. So let me just execute this. If this execution is completed, we'll execute our third query. Remember, compared to the first query, the only difference this time is this is not round robin, this is hash distribution, and we need to see that how this hash distribution is actually performing. Query executed successfully within 39 seconds, almost similar kind of time. 60 records are inserted with this. Now this query I'm removing, and I'm saying that I want to see the distribution, order ID, all those things actually into this one. For one table, the name of the table is going to be orders2. This is also a same query which I have executed earlier, but this time the only thing which I'm changing is the name of the table. When I want to see this query for orders2 table, let's see that what is coming here. You can see I'm getting same kind of details. We have table name which is orders2. We have a node ID which is going to be same for all 60 records, which is 50 because we still have only one node. Distributions ID are going to be start from 1 to 60, but somewhere in one of the distribution, we have all 60 rows which are processed. It means this time the execution was totally different. This time actually, it's not like multiple distributions are randomly and evenly getting a chance to insert the record. This time, because the hash column is actually order date, and because we have same value in that order date column, every time the same distribution ID is going to be used. So it's like this is the only one distribution which is playing an important role to execute this query, and that's why all the rows, all 60 rows are actually executed by the same distribution. I know logically this is illogical actually. If I give my hash column as order ID, then maybe my distributions are going to have different records associated with that. But this is just to show you that based on the hash column, this is going to do the distribution, and based on that is going to process the rows. That's why deciding which kind of distribution in the table and what kind of column will be the right hash column is a very important thing to understand. Before we proceed, let me try one more thing. These are the two different tables which we have created. I want to create actually one more table. This table is going to be again with the name orders, but this is going to be orders3 actually. Let me just do it once again. I'm going to create my one more table. This new table is actually going to be orders3 table. Everything is same. This is going to have a round robin distribution. It means very much similar to the first table actually. I'm going to execute this. But this time, before inserting any records into this orders3 table actually, I want to do one thing. So this table is executed, this query is executed, and if I refresh this, this is going to show me orders3 table. But the orders3 table is actually empty right now. This is not having any kind of records inside that. Before I add any records inside this, what I'm going to do is, I'm going to scale my dedicated SQL pool. So I'm going into the scale section, and I'm saying from DW100C, I want to scale this to DW1000C. Remember, as per this table, when you go to DW1000C, this is going to be a scale out architecture where horizontal scaling is going to happen. And now I'm going to have one more compute node associated with this. So it's not going to be only one compute node, it's going to be two this time. If I scale out this thing to DW1000C and then if I save it, this is going to take some time. This is something which is a scaling process which is initiated, and during the scaling process you won't be able to execute any query here. So because the scaling is actually undergo right now, I should not be able to execute any queries here. It's going to show me a warning here that dedicated SQL pool is right now scaling. So please wait first till the scaling is done. Once scaling is done, then we can proceed and we can execute further queries. And let's wait for a few seconds. Let's wait for a few minutes. It will be done within, I think, 3 to 4 minutes. Okay, my dedicated pool is actually now scaled. So you can see it's showing me scaled here. And if that is done, then let's go back to this particular query section. And what I'm going to do is I'm going to execute my third query, but this time I'm going to execute this thing for my orders 3 table. Let me copy that query. Let me put it here. And now I'm going to change the name of the table to orders 3. This third query is actually going to execute this particular section. Now in this section, we are going to execute our second query first, and we are going to insert some records, same like what we have done in the first 2 tables. I'm copying my second query, pasting it here. The table name, I'm going to change it to orders 3. Everything else is same. We are going to insert 60 records with this. And if the 60 records are inserted, then we are going to execute the third query, in which we are going to see what kind of execution is happening. Remember, the third table is having round robin distribution. So this time there is no hash column, there is no hash distribution. Let's wait for some time. This time it's going to execute logically in 2 different compute nodes. My query got executed, so it means 60 records are actually inserted successfully. Let me delete this query from this script section. And now it's the time that we have to execute our third and the final query, which is going to show us that what kind of distributions are used this time. I'm going to change the table name to orders 3. I'm going to execute this query, and then this time let's see what kind of output we are getting. Yes, output is coming here. You can see table name is order 3 for all the records. In the node ID, they are showing me that 2 different nodes are actually performing this operation this time. Node ID is 29 for the first, I think, 30 records, and for the record number 31 onwards, we have another node which is playing important role. It means here we have parallel executions which are happening in 2 different nodes, which are going to be my compute nodes. Because the work is distributed and execution is happening parallelly, this is going to be much faster than the previous one actually. Also, you can see here distribution is actually round robin, so we have a similar kind of output in the distribution. Some distributions are having 2 or 3 records, and some distributions are actually having no records processed by that. It means it's again randomly evenly distributed across all the distributions which are available in that. Same way, if I try to achieve the similar kind of thing with hash distribution, then it's going to give me based on the hash column, but I have to create a proper hash column for the table. I hope you understood what I'm trying to putting across with this transactional SQL queries. These queries are actually showing you that the query execution which you're doing in this SQL server is not like a traditional normal SQL server. This is a data warehouse. And if this is a data warehouse, you have to use the performance power of the data warehouse, which can give you up to 60 compute nodes associated with this thing and 1 control node associated with this. So this is how you have to query. This is how you have to create a structure of your database table. I hope you're getting this. I'll see you in the next video.